Welcome, ladies and gentlemen. Today we're going to start chapter 10, all about circles. Particularly today we're going to talk about properties of tangents. So you're going to need to make sure that you have your guided notes, a pen and or pencil, and a calculator, please. All right, let's get started. This first slide we kind of have a lot is our circle vocabulary, but it's very important. So please make sure you have all of this down. A circle is a set of all points that are equal distance from the center. The center, a point in the middle. Radius, the distance from the center to the edge of the circle, to the circle. The diameter is the distance across the circle that passes through the center. Now those top ones we probably already know. The next three might be a little new to us, so make sure you get all these down. A chord is a segment whose endpoints are on a circle. So they don't go through the center, but it does touch two parts of the circle. A secant, it's a line that goes through the circle. Okay, so it's a line that goes through a circle. A chord is a segment, a secant is a line. And last but not least, we have a tangent. It's a line that intersects a circle at just one point. Okay, so please make sure that you have all of this written down before you move on. All right, here's our next part. We're going to add to that large circle that's on your guided notes, and this is what we're going to put in. We're just going to put in all those vocabulary words that we've already just talked about. Make sure that we have an idea here. So we have a radius, which is here, from the center to the edge. A secant is a line, so we make sure you go through and you put arrows on that, okay? Because a secant is a line. A tangent goes through one point. Okay, just one point, so just make it touch one little part of your circle. A diameter, make sure we go from one point to the other and goes through the center. And a chord is just from one point of the circle to another point of the circle. But remember, it's a segment, so it starts and stops. All right, that's all we have for that one. Now I have this example. You can write it down if you want. It's not part of your guided notes, so you don't have to have it. But we're just going to go through and make sure we can identify these things. We're going to tell whether the line or segment is best described as a radius, chord, diameter, secant, or tangent of circle C. And you guys, that's what this represents right here. This right here means circle C. C is the center, so that's why we call it C. So if we look at this circle and all of these lines and segments, we want to know what this means segment DC is. So if we look from D to C right here, it goes from the center to the outside of the circle, so that is the radius. Now if we move on to B, we're also talking about a segment. Segment, BD. So from B to D, they're not talking about the line, they're talking about the segment. So this is going to be a chord or secant. Sorry, if they were talking about a line, it would be a secant. If they're talking about a segment, it's going to be a chord. So we can think about that as being both. Now if we talk about line, DE, so we are going from here to here. We are going to be talking about the diameter. And last but not least, if we talk about line, AE, from here to here, it only touches one point on our circle, so this is a tangent. All right, moving on to that next page of our notes. Tangent, to touch at one point. It's really important, only at one point. It's typically a line is a tangent to a circle. So we're going to talk a lot about that. Now, common tangent is a line, ray, or segment that is two or more circles share. So make sure you have that. And these are some examples of what a tangent looks like. This is a tangent line that touches two circles, so it's a common tangent. It is shared between two circles. This one's also a common tangent because it's shared between those two circles. Okay, make sure you get that down in your notes. Now we're going to move on and we're going to be drawing our own tangents. So we have 4 examples and we have to tell how many common tangents the circles have and draw them. So if I look at example A, I want to draw as many tangents as I can. So it has to touch the circle at least 1 point. So if I look at this one, I can create a tangent that goes along the edge here. So there's 1. And I can also create a tangent over here that goes along this side. So that's 2. So on A, I can only have 2 tangents. Now if we move on to B, we're going to think of the same thing. We can start the same way we started A. We can draw them on the outside. So I have 1 tangent here. I have my second tangent here. Now I have to get a little bit more creative because I have more than 2 tangents on this one. I can go across like this to get another tangent. I can also do that exact same thing going the other way. So I can go across like this to get another tangent. Now I'm out of tangents. So B, I can have 4 tangent lines. Common tangent lines. I should rephrase that. Now C, if we look at C, C is also very similar to A and B, but so we're going to start by putting our tangents across the edge. So I have 1 and 2. Whoops, kind of missed that one. 2. And now there is one more, ladies and gentlemen, and that one more, if we see these 2 circles touch at 1 point, so I can draw a line straight through it. So this one has 3 tangents. Now last but certainly not least, we're going to look at our final example here. And if we see there's circles inside of circles, but they are touching at 1 point, so I can draw a tangent line across the bottom of this one. So this one has 1 tangent. All right, so those are examples of our common tangent lines. So make sure we know how to draw these. Make sure you can identify where you can see common tangent lines. All right, moving on up. We're going to talk about some more circles. So these circles share the same center. So if you want to get this example down, please, we have 1 circle, and then we have another circle, and another circle, and once again, 1 more circle. But what's really important, you guys, is that they share the same center. So all of these circles would share this center. Okay? So they're equally all spread out. So it's just kind of like a bullseye if you want to think about it like that. All right. Here we go. Now we're going to move into some examples. So AB is a tangent, and we need to calculate the radius. So if we look at this, tangents create right angles with our radius right here, okay? It's very important for us to know. If we look at this, we see this right away. We have a right triangle. And we know how to solve right triangles. We're going to use Pythagoras' theorem. So we have a squared plus b squared equals c squared. So I'm going to call my 12a, my r is going to be my b, and this right here, since it's across from my right angle, is my hypotenuse, or my c. So when I plug this in, this is very important, ladies and gentlemen, how we're going to do this. This is going to be 12 squared plus r squared equals. Now, I have from here to here is my radius. And from here to here is 8. In order to know what my C or my hypotenuse is, I have to add those together. So here I'm going to put parenthesis r plus 8 squared. Now, before I get too crazy and get going here, 12 squared is 144 plus r squared equals. Now, when I have something like this, ladies and gentlemen, squared means multiplied times itself. So I'm going to have r plus 8 times r plus 8. That's what that means. That's what r squared means. Now, in order to solve this, I'm going to have to distribute this side before I do anything with my other side. So I'm going to keep this as 144 plus r squared equals. Now here, r times r is r squared plus 8r plus 8r plus 64. Now we can keep going here so we can have this problem solved. So I get 144 plus r squared equals r squared. Combine like terms here, so I'm going to get plus 16r plus 64. Now, if we notice, I have two r squareds. I have one here and here. So I'm going to subtract r squared, and both of these are going to cancel for me. So I'm going to get 144 equals 16r plus 64. Now I can go through and I can solve for r. So I'm going to subtract 64 from both sides. And I'm going to get 80 equals 16r. Now to solve this, I'm going to divide both sides by 16. And my radius, ladies and gentlemen, is going to be 5. So you will have a problem like this, so make sure you know when you square something, it means we're multiplying times itself. All right? All right. Here we go. Moving on. Almost done. A tangent segments to a circle form a point outside a circle are congruent. So if tangent segments come together at a point outside the circle. So here's tangent number 1. Here's tangent number 2. And they meet at a point outside the circle. When this happens, ladies and gentlemen, these two segments are congruent. Okay? It's very important for us to know. So this segment is congruent to this segment. All right, so make sure we have this down in our notes, please. All right, moving on to our very last example. We need to solve for x. Now, we just discussed this. We know that this segment, because it's a tangent in this segment, and they meet at the same point, those two segments are congruent. So when we solve this one, we're going to have 5x minus 4 equals 2x plus 2. Now we're just going to solve this for x. So subtract 2x from both sides. I get 3x minus 4 equals 2. Add 4 to both sides. Those cancel. 3x equals 6. Divide both sides by 3. And x equals 2. And there we have it, ladies and gentlemen, our answer. All right, that is all I have for you today. I hope you go out and have a fabulous, wonderful day, and I will be seeing you later. Bye.